Welcome to the Serial Dilutions video for UAB's Gen Chem 1 lab for summer 2024. This video was made by Parrish Zena, Joey Sousa, and Dawson Doe. We want to get to the experiment, but first we got to define a couple of things. First we're going to compare a stock solution and a dilution, then we're going to define a meniscus. The stock solution, which in this clip is on the far right, it's the darkest blue one, is essentially your base solution, and it's the one that you create your first dilution from. If you're doing a serial dilution, the next dilution would come from the first dilution, and so on and so forth. The difference between a stock solution and a dilution is the stock solution will have the highest concentration of all of your solutions.
A meniscus is the strong attraction of a liquid to its container to cause a concave curve in the container. And to read it, you need to read at the bottom of the meniscus and record to the number of uncertainty that your container measures. A meniscus occurs when the liquid has a strong attraction to the container it is in. So, for example, water will have a strong attraction to the glass it is in to cause a curve in the liquid.
Experiment time. What do we do first, Dawson?
You want to get some reagent, but you don't want to get excess, as that means you'll have to throw it out because you don't need that much. You just need enough to do 3 serial dilutions.
Then you pipe some of your solution from your piping beaker into the pipette and measure the meniscus. This one, it's tricky to see because of the paper in the background, but it's close to the 1.6 mark. So I'd say it's about 1.59, meaning in the pipette right now there are 8.61 mils of solution. Then pipe some into the volume graduated cylinder, then measure the meniscus of the pipette again. Don't measure the meniscus of the graduated cylinder because it will give you an incorrect number. It will give you the final volume minus the initial volume, so the difference in volume, but that doesn't really help you in this situation because if you want to record the final volume. So measure the meniscus of the pipette again.
So we have about 10 milliliters in here.
No.
It's
we gotta do
below 10.
I'll say it's around like
It's
9.82.
yeah.
And then once you do this, you pour some of the reagent into the 25 milliliter volumetric flask, and then you want to record this value as the initial value, and then you add water until the mark,
which means that the volume of the volumetric flask, like the actual volume of it, like if it's a 10 mil volumetric flask, which is what's in this clip, your final volume is going to be your final volume. So in this case, for this clip, the final volume was 10 mils. And you'll also see that we're piping this stock and we poured in the water from the graduated cylinder. As long as you have the right volumes for specifically the water, because you'll be using the previous dilution to make the next, it'll still work fine.
And then once you finish all of this, you want to follow proper cleaning procedures by washing all the glassware and pouring the solutions down the drain with running water.
So we created a calibration curve with sugar solutions from 20% stock to 10%, 5%, and 2%. And we determined the unknown concentration from the calibration curve. So you can find out what that what you need to make the concentrations to be from the stock solution by using concentration 1 times volume 1 equals concentration 2 times volume 2.